So this is the last of the properties that we have for exponents. We're going to cover them today, the last two. For the main one we're dealing with is division. So if I have 4 to the 5th over 4 cubed, that's 4 times itself 5 times, 1, 2, 3, 4, 5, over 4 times itself 3 times, right? Well, if you look at this, you can reduce. This is reducing. You can reduce this. If you're doing multiplication, same thing top and bottom. Any matching numbers cancel each other out. So when I do that, I have 2 4s, which means that I have 4 squared. Okay, that's what that is. That's what you're doing here. Technically, that's what you're doing. However, there's obviously going to be a rule that's going to be applied here, because it's what this whole chapter is all about. There are all these rules. How do these two numbers relate to that number? Anybody see that? Subtract. When you multiply, what do you do when you multiply? You add. So when you divide, what are you going to do? You're going to subtract. So this would be 4 to the 5 minus 3 power, and 5 minus 3 is 2. So if I look at this one here, this is x to the 12 minus 5 power, which is x to the 7th. 12 minus 5 is 7. Okay? You multiply, you add the exponents. When you divide, you subtract the exponents. All these rules are very closely related. To me, it makes sense. Multiply, add, divide, subtract. Okay, that kind of addition, subtraction, multiplication, division, they are related to each other in the same way. So our rule is, if you're dividing powers with the same base, subtract the exponents. That's our rule. Now, there's another shorthand for this I'm going to show you in just a second. But if you're dividing powers with the same base, you subtract the exponents. So if I apply this rule to the one that I have here, c to the 4th divided by c to the 7th, that's c to the 4 minus 7. And I do my subtraction, right? What is 4 minus 7? Negative 3. So this is c to the negative 3 power. But what are we not allowed to have in our final answers? Negative exponents. So what do? Our rule says, oh, we put it in the denominator and make it positive. Equals 1 over c cubed. However, there is another rule that we can apply for the same thing. It kind of shortcuts dealing with the negative. Okay? So our other rule, and this is kind of the same one, is you ask yourself, where do I have more and how many more do I have? So there's a trick to this when you're doing division of where to put the answer, whether it goes in the numerator or it goes in the denominator when you do division. Okay, so there's a trick to this that you can use. So you can do what we did here, 4 minus 7, negative 3, and then put it in the denominator. That's okay. That works just fine. But there is another way of doing division. And this is honestly what I usually do when I'm doing this, when I'm working out problems with this. Is you ask yourself, which exponent is larger? The one in the numerator or one in the denominator? Which one's bigger on here, on this one? We're working the same problem. See the 4th over see the 7th. 7's bigger than 4, right? So my answer is going to go where the bigger one is. I still subtract. But I don't take 4 minus 7. What I do is I go, okay, this will be 1 over c to the 7 minus 4 power. I do my answer where the larger of the two exponents are, and I take the big exponent minus the smaller exponent, and I get 1 over c cubed. I get the same answer. And that's technically what I did here. Where's the bigger one at? It's in the numerator. 12 is the bigger one. So I did 12 minus 5. I get x to the 7. If you take the bigger one minus the smaller one, you will always have a positive exponent, either in the numerator or the denominator. Two different ways of doing it. I really don't care which one you use. Second one is the one I tend to use, but I do this an awful lot, so it doesn't bother me one way or the other. Okay? So let's do some examples here. Yeah, I know. It's the only one with fractions in it. We'll deal with the fractions, so that's not big a deal. So I have to do subtraction, right? Because I'm dividing. So this would be x to the 3/2 minus 1. That's what that is. And then you have to do the subtraction. Now you have your calculators. I don't think any of your homework has a fraction on it. 3/2 minus 1. That's 1.5 minus 1. 5x to the 1/2 power. And yes, fractional exponents are a thing. If you get to algebra 2, you will be doing fractional exponents because they are a thing. Okay. Now I need to do the next one. This is where it's a little more complicated. It's not bad, but it's a little more complicated because I have two variables I'm dealing with. I'm dealing with my m's, and then I'm going to deal with my n's. You do them one at a time. You work one variable at a time. So I ask myself, what's bigger, 5 or 2? 5. So that means my answer is going to be in the denominator where the 5 is. So I end up with m to the 5 minus 3, which gives me m squared in my denominator. So that's just my m's.
It's a 2 up top.
Yeah. Oh, 5 minus 2. Thank you. My bad. I get carried away and sometimes put the answer in the problem. Okay, now I would deal with my n's. This isn't that bad. What's bigger, 4 or 3? 4. And where's the 4? It's in the top. So my answers are going to be in the top. N to the 4 minus 3 power. See, I did the same thing again. I put the answer in the problem. And then, so that would be n to the first. Now, do we normally write the first power there? That's a 5 minus 2.
No, on the, like, before.
It was a 2 that I screwed up, and it wasn't supposed to be a 2. No, so the end of the first power. Do we write ones for exponents in our final answers? Should that be there in our final answer? No. Is it okay if it's there? Yeah, if you did that on the test or something, I wouldn't care. But honestly, it looks better without the single power on there. Now, a new rule-ish. Okay, when we have things that are multiplied raised to a power, we raised everything to that power. If we have division, everything inside here gets raised to that power as well. Everything inside gets raised to that power as well. So when I have x cubed over 5 to the third power, that third power gets applied to both terms. So in this case, I end up with x cubed over 5 cubed. That 3 exponent applies to everything. Okay. What do I do to these exponents on the x? I multiply them. It's a power to a power. You multiply them. So that gives me x to the 9th. And then you want to do 5 cubed. If you left it as 5 cubed, that's okay. But really, it's not that big a deal to do that on your calculator. You should get 125 for that. Questions? It's following the rules. And the rules are fairly consistent across the board. Next one, same thing. I take everything in here to the second power. Everything inside here, everything, it's all multiplication and division. Everything that's inside the parentheses gets taken to the power outside the parentheses. So I multiply this 2 times every power that's there. So I have 2 squared, a to the 6th over b to the 4th. 2 times 1, 2 times 3, 2 times 2. Now, what should I do to clean this up a little bit more? Yeah, make the 2 squared into 4. It just looks a little prettier. And often a lot of the things that we do in math really don't make anything in a difference in value. They just make them look prettier. Okay. It's 2 squared and 4, they're the same thing, but 4 looks prettier than 2 squared. Honestly, that's what we're doing. Okay, questions on that one? Okay, these last 2 have a little twist to them. Our exponent on the outside, what's different about the exponent on the outside on these 2? They're negative. Okay, we don't want negative exponents. And if I had the whole thing raised to a negative exponent, I don't distribute that negative exponent first. Because then I'm going to have a negative and a negative and a negative, and I got to worry about moving crap around. If I have something like this, my first step is to flip the fraction inside and make it a positive exponent. If I have a negative, if I have an entire fraction inside raised to a negative power, I flip the whole fraction over. But remember, it's only if that whole fraction is to the negative power. And then I just do what we got done doing. I take this to the second power, I take that to the second power. So I get y to the 4th over x squared. Piece of cake. So my first step in this one's going to be what? Flip it over and make it a positive exponent. Y to the 4th over 2x to the 6th to the third power. Flip it over, make it positive. And then from here, I follow the rules I've been following. Take that 3 and apply the 3 to the power of everything else. So I get y to the 12th, 4 times 3 is 12. 2 to the 3rd, and x to the 3 times 6 is 18. And I should do one more step. Get rid of the 2 to the 3rd power. What is 2 to the 3rd power? Nope. 8. 2 to the 4th is 16. So I get y to the 12th over 8x to the 18th. Question? Okay.